now we are going to see the topic about semaphore. It is the main and the important topic of operating system concept. So first of all, what do you mean by semaphore? Semaphore is the synchronization tool. You know about that, monitor, some hardware, synchronization hardware, etc. Likewise, the semaphore is a synchronization tool. So what is the use of this synchronization tool? We are going to discuss about this synchronization tool. Means, first of all, we should know about the critical section problem. So what is the critical section problem? Each and every process P1, P2 and etc. Pn, each and every process must execute within the system. So each process and its segment codes are categorized into three main sections. See that this is the entry section, critical section and the exit section. So each and every process segment codes are categorized into three sections. Usually the system executes the three sections one by one and without any problem. But whenever the system executes the critical section problem, it must face lot of problems. That means no more other process will be interfere in the execution. So these types of problems we may face. So that this section is called as critical section. So whenever the system executes the critical section of particular process, the system does not allow any other process inside of the critical section. That means each process critical section is executed by the system. At the same time, the system should not allow any other process inside of the critical section. So at a time, it must execute only one process. So that is the critical section problem. So to avoid this critical section problem, lot of requirements are there. You see about the mutual exclusion and the circular weight problem. Two process synchronization solutions, multiple process synchronization solutions and the synchronization hardware, etc. Likewise, we are going to see the synchronization tool like semaphore. So first of all, semaphore is indicated by the integer value of capital S. Okay, the semaphore value is maybe first it assigned as 1. So which process want to execute the critical section, at first the process keep it the semaphore value and assign the semaphore value is equal to 1. Once the process assign the semaphore value is equal to 1 means no other process cannot be changed simultaneously the semaphore value. That means if now the P1 assigned the S is equal to 1 means the P2 and P3 and up to Pn etc. it cannot be changed the semaphore value. Okay. Then first then second part is we are going to see about the two main operations. So what are the operations done by semaphore? First one is the integer variable. Semaphore variable, there is a variable, and second one is two operations. So what are the two operations performed by semaphore? These operations are, first one is wait and second operation is signal. Okay. Now see that the wait operation is may be denoted by down operation, down off. The signal operation is may be denoted by up operations, up off. Then another one, it may be the wait operation is denoted by the letter P symbol, P off. And signal operation is denoted by the V off. So it may be denoted in three ways: wait operations or down operations or P off functions. And signal operation, up operations or V off functions. So the two main operations done by semaphore. Okay. Now the process structure segment code is this one. So entry section is take over by the wait operation. This is the main intersection of the each process take over by the wait operation. Same like that, the exit section of each process is take over by the signal operation. Okay. So whenever the process enter into the wait operations, it does not, it will be set the semaphore value is equal to 1. And when it is enter into the critical section, it is set the value is decremented into some value 0 and etc. So when the value is not equal to 1 means the process, no other process enter into the critical section. That is the main condition. Okay. Okay. Next, we are going to see the syntax of wait and signal operation. Already I explained the same thing. The intersection carried by the wait operation of semaphore. The exit section is carried out by the signal operation of semaphore. Okay. So what we are going to do in the wait operation. Okay. Now the variable is two process P1 and P2 are coming to execute critical section. Now the variable yes, already we know, we already discussed about that, the semaphore variable, integer variable. At first the integer variable s is equal to 1 for assigned for the process P1. Okay, now the P1 get the integer variable and then enter into the execution of wait operation. Okay, now s is equal to 1. Then you can check the condition, s less than or equal to 0. The condition is false automatically. Okay, then next it go to decrement the s value. So the process P1 decrement the s value, so it is decremented or changed into 0. Okay, now at the same time the process P2 want to execute the critical section, means now we take over the s value. So we check the value, s is equal to now 0 by P2. So P2 take the s value, now s value is equal to 0. So check the condition s less than or equal to 0 means it will be trapped by the particular loop. So the P2 does not allow inside of the critical section. It will be trapped by the while condition. That is a operations structure. Okay. Next we are going to discuss about the signal operation. So wait operation is intersection of the particular process. Okay. Next critical section. You see that the wait operation is intersection of the process. Next critical section, the process successfully executed the intersection means it will be enter into the critical section. Then after completion of the critical section problem, it will be enter into the signal of yes. That means the signal is perform the exit operation, EXIT. So when one process P1 example it will be enter into the critical signal operations, means it will be it wants to exit from the critical section operation and also give the chances to another waiting processes. So when it enter now the process P1 is enter into the signal of s, means the s value already we know about that, s value is equal to 0, because now the s value is equal to 0. Then it will be want to exit from the its execution, so it automatically incremented the s value. So now s value changed into 1. At first wait operation s value is 1, then it will be decremented by the process P1. So the process P2 cannot enter into the critical section. Now it will be changed the s is equal to 1 in its exit operations. Okay. Now the s value is 1. So the P2 hold the s value. Now s value is equal to 1 means now P2 enter into the critical section. That means the P2 have chances to enter into the critical section. Likewise, the wait and the signal operations are performed. So at first, once again I repeat the same. The wait operation is act as a intersection. We successfully executed the intersection, means no other process enter into the main critical section process. For that reason, we are going to set the s is equal to 1 means the process enter into the critical section. When the s changed into s equal to 0 means no other process enter into the critical section. Okay. Now I am successfully completed my execution, means the process P1 go to give the chance to other P2 process. For that reason, the signal of s will be incremented. So then after the s variable is assigned to P2, P3, P2, Pn, etc. Okay. Now the main condition is P1, P2 are wants to execute the critical section. Now the P2 is not allowed into the critical section, so it will be trapped out by the particular loop. So these types of waiting process are keeping some queue. So we have maintained some queue, and P1, P2, P3 up to Pn process are come on to execute the critical section. But already the P1 process is executing mode. So the waiting process are keep and placed in some queue. P2, P3, Pn. So that is done by two main operations.